Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in to this video in which we review angles and parallel lines. We're going to go through 4 types of special angles when parallel lines are involved. So these arrows on lines imply that they are parallel, which of course means that even if these lines were to go on forever, they would never meet, going in the same direction. So we'll start by looking at vertically opposite angles. So this angle here in blue and this angle here in red, they're supplementary. This angle plus this angle equals 180 degrees because they make a straight line. But we also have this angle here. This one and this one add to 180. This one and this one add to 180. The only way that's possible is if these two angles are equal. The two blue angles are equal. Similarly, the two red angles are equal. And it's the same down here as well. This angle and this angle would be equal. This angle and this angle would be equal. So vertical means like standing up. Opposite means facing each other. Vertically opposite angles are equal. Let's look at co-interior angles. So they're different to the other three in that they are not necessarily equal. They're supplementary, meaning they add to 180 degrees. So the two angles that are co-interior are this one here and this one here. This angle plus this angle equals 180. They're called co-interior. They're both interior inside the two parallel lines. So co-interior angles make a C shape around them like this. The C, however, can be back to front like this. So it turns out that this angle here and this angle here are also co-interior. These two angles add to 180. These two angles add to 180. They're not necessarily equal. So because of that, we can look at this angle here and this angle here. So I know that these two angles are co-interior and they add to 180. The blue angle plus the red angle is 180. But I know that this angle and this angle add to 180 because they're supplementary. The only way that's possible is if these two angles are equal. Similarly, these two blue angles are equal. So alternate angles make a Z shape. It can look like that. It can also be a back to front Z. They're alternate because they're on alternate. They're on different sides of this line that cuts called the transversal. So this angle and this angle are alternate. They are equal. If this was 80 degrees, this would be 80 degrees. These two angles here are alternate. If this one was 100 degrees, that one would be 100 degrees. So finally, for corresponding angles. So I know that this angle plus this angle, red and blue, add to 180 because they're co-interior. So this angle here in red, it also adds with the blue to get 180. These two are supplementary. So the only way that's possible is if the two red angles are equal. Similarly, these two blue angles are equal. It turns out that these two red ones are also equal, and so are these two blue ones. So corresponding angles make an F shape like this. This angle and this angle are corresponding. Corresponding angles are equal. If this was 50 degrees, this would be 50 degrees too, and so on. So we can use all this to find unknown angles. Let's have a look at that now. So in each of these diagrams, we will find the value of x. So let's look at this first one here. So you have to identify what kind of angles do we have. So if I draw a shape around them, these actually make a C shape. These two angles are co-interior, meaning they add to 180. So x will just be 180 minus 95, which is equal to 85 degrees because they're co-interior. So let's look at this one here. Now this one's a little more tricky, reason being because x and 75 are not any of the special angles that we went through. They're not alternate, they're not corresponding, not vertically opposite, not co-interior. Sometimes I need to find another angle first before I can find x. So, as an example, I could find this angle here. This angle here would be 105 degrees because these two are supplementary. They make a straight line, they add to 180. This angle here is 105 degrees, but it's actually alternate to x because we make the Z shape here. As I said, it doesn't have to be a normal Z, it can be a Z on its side, back to front Z, whatever. So x, this angle here, is equal to 105 degrees, and the reason it's alternate to that blue angle there. So let's look at the third diagram now. Same idea here. These two angles are not vertically opposite, they're not corresponding, alternate, or anything like that. I need to find another angle first. So I can notice this angle here must be 80 degrees because these two angles are vertically opposite. Vertically opposite angles are equal. So now that I've found this angle, I can find x really simply. This is the F shape we were talking about, although it's a back to front F. These two angles here are corresponding, so they must be equal. So x must be 80 degrees because it's corresponding to that other 80-degree angle I just found. All right, the last one is a little more tricky. Sometimes what we have to do is construct another parallel line. So x and these angles, there's no alternate vertically opposite angles here. But if I construct another line through here that's also parallel, I can actually find x really simply. This angle here is alternate to the 110-degree angle, so it's 110 degrees. This angle here is co-interior to the 60-degree angle. They make this C shape. So the angle I've marked green would be 120 because they need to add up to 180. So that's really easy to find x. It's just 110 plus 120, which is 230 degrees. So that is an alternate angle plus a co-interior angle. All right, there's just one more concept we need to go through, then we're done. So it turns out we can also use this idea of alternate corresponding and co-interior angles to determine whether or not lines are parallel. So that stuff I said before about these three types of angles only works if the lines are parallel. Alternate angles and corresponding angles are equal if and only if the lines are parallel. Co-interior angles are supplementary if and only if the lines are parallel. So looking at this diagram here, we're asked are the lines parallel. We can't just look at these two lines and say, oh yeah, they look parallel. We need a reason. So these two angles are co-interior, and 80 plus 100 is 180. Here we have two co-interior angles. They are supplementary. They add to 180. So therefore the answer is yes. These two lines are parallel because co-interior angles add to 180 degrees. So let's look at this question here. Again, we can't just look at the two lines and say, oh yeah, they look about parallel. So notice up here I didn't mention anything about vertically opposite angles. That's because vertically opposite angles are equal regardless of whether or not the lines are parallel. So this angle here will be 80 degrees because it is vertically opposite this angle. It doesn't matter whether or not these two lines are parallel. But if this angle's 80 and this angle's 90, we have a problem. We have two angles that are corresponding, but they're not equal. So because the two corresponding angles are not equal, these two lines are not parallel. If they go on forever, they will eventually meet. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.